For class today, we looked at elimination. It's our first day of it, so it's our third technique to solve a system. The steps to solve a system by elimination, the first thing is you have to align the like terms. So when you have your two equations, what you want to do is you want to line them up vertically, and you want to make sure that everything's lined up appropriately. X's are over the X's, Y's are over the Y's, equal sign is over the equal sign, the numbers are over the numbers. Once everything's in the same style, we can use elimination. So elimination does not work if one is in standard form, like this. You can't have this. You're like, well, the numbers are lined up. Yeah, but nothing else is. Everything has to be lined up correctly. And if it's not, you have to change it so it is lined up. We're going to practice that on Monday and Tuesday of next week. So once you've checked and everything is aligned vertically, you want to find or make one variable have the same coefficient. So when you're looking at the system, it's all lined up, you're going to want the x's both have the same number in front, or the y's the same number in front, or in the very least have the same basic number. So if one's a positive, one's a negative, we can work with that. But you want them to be the same absolute value. Then step number 3, we're going to add or subtract the equations together. We're going to set up a giant addition or subtraction problem to hopefully eliminate one of our variables. That's the whole goal, is when we do this addition part right here, this is where this method gets its name. Something should be eliminated right here, either the x or the y. Step number 4, you're going to solve the equation that happens. Bring us to our final step, number 5. We're going to plug in the result. To get our second point. So by eliminating it, you're going to get x or y, and then you plug it in just like substitution to get your other value. All right, so let's take a look at our first example here. So the first thing you want to look for is everything perfectly lined up. X is over X, the Y's are over Y's, equal signs, numbers over numbers. They're askew based on the formatting of the computer, but everything's in the same relative position. We're good. The next thing we want to look for is, do one of our variables have the same number in front if we don't care about sign? In this case, yes. The x's both have a 2 in front. One's negative, one's positive, but we can work with that. I need to create 0x. That way it gets eliminated right here. Because one's positive and one is negative, we're going to add the equations together. That way it's negative 2 plus 2, which creates 0. We're going to do the rest of the equation as well. So the negative 2 plus the positive 2 gives us 0x. The negative 6 plus positive 8 gives us a positive 2y. The negative 18 plus 32 gives us a positive 14. By doing it this way, our x term has actually been eliminated, and we're left with this resulting equation. I divide both sides by 2, and y equals 7. Just that quick, I have half of our answer. Now I need to go and find the other half. To do that, we're going to pick one of these equations, either 1 or 2. Doesn't matter which one we pick. I'm going to pick the second equation just because there aren't any negatives. It looks easier. That's all just a personal preference. I'm going to plug the 7 in, which we know is y, right here. 2x plus 8 times 7 equals 32. 2x plus 56 equals 32. We subtract 56 from both sides. Get 2x equals negative 24. Divide by 2, and x is negative 12. And we've solved by elimination. So we set it up. We added the two equations together to eliminate the x's that are here. Solved our equation. We then plugged in the result into one of our equations to solve for our other point. So again, we want to check this first part of the problem. Is everything lined up? Yes, the x's are lined up, the y's are lined up, equal signs are lined up, numbers are lined up. And we luckily have 3's in front of both of our y's. Again, 1's plus, 1's minus. So we're going to add everything together. So 12x plus 3x gives us 15x. 3 plus negative 3 gives us 0y. Negative 21 plus negative 9 gives us negative 30. Because we eliminated the y's, we don't need it in our equation, so it looks like this. Divide both sides by 15, and x is negative 2. Only half of our answer, so we want to go find the other half. We can either pick the top or the bottom equation. I'm going to pick the bottom equation just because the numbers look smaller, therefore hopefully simpler, but not necessarily. X was negative 2, so we replace it in the equation. Negative 6 minus 3y equals negative 9. Add 6. That gives us negative 3y equals negative 3. Divide both sides by negative 3, and y is 1. So you might be wondering, all right, what happens if we have the same number, but they're the same sign? Like this one. Everything's lined up. Our x's have the same number in front, but they both happen to be positive. I still need to create a 0x, so 5 minus 5 is going to give us that 0. So I'm going to take 5 minus 5, 0x, 11 minus 12, negative 1y, and then negative 25 minus negative 30, if we were to write it out, looks like this. Negative 25 minus negative 30 is positive 5. Divide both sides by this negative 1 because we don't want a negative y, we want a positive y. And there's our answer. Again, that's only half of our answer, so we're going to pick one of our equations. I'm going to pick the top one just because it looks slightly simpler. I'm going to plug in negative 5 for y. (11 times negative 5 is negative 55. We add 55 to both sides. We get 5x equals 30. So we divide both sides, and x is 6. The same is true if both of our numbers, I thought this one, do I have another one after this one? No. So I'm going to slightly tweak this one because I want it to be So I'm going to make it 10x minus 12y equals 26. 8x minus 12y equals 28. So I'm going to make all of them switch signs, is what I just did. So I don't need this one anymore. Thought I saved this one as a double negative, but I didn't. So maybe our system, our y's are the same number, but they're both negative. The same process. Because they're the same sign, we're going to subtract. 10 minus 8, 2x. A negative 12 minus a negative 12 is a 0y. 26 minus 28 is a negative 2. We don't technically need the 0y, so I'm going to erase it. We divide both sides by 2, and x is negative 1. Pick one of our equations. I'm going to pick the bottom one. 8x minus 12y equals 28. So I get 8 times negative 1 minus 12y equals 28. That's negative 8 minus 12y equals 28. So I have to add 8 to both sides. Remember to bring down the negative 12. Divide by negative 12. And y is negative 3 for our answer. And that is our introduction so far to elimination. We're going to look at what happens if they don't have the same coefficient in front. We're going to have to make one of them be the same. We're going to do that on Monday and Tuesday next week.